My pleasure to be invited into Data Popcorn this year. My name is Vitalija and I'm a data engineer. And today I want to introduce you to one of my favorite R packages of all times, which is called ggplot. And it has been originally created by Hadley Wickham in 2005. And it has been grown to be one of the most used R packages of all times. And there are many reasons why. I look forward to dissect it with you today in this short video. But first, let me introduce myself. My name is Vitalija, and by education, I'm a biologist, but now I work as a consultant data engineer. And primarily, I work with Azure Databricks. My previous experience includes working with ADF, Power BI, and Synapse. Today, I want to invite you to play with some data in Databricks. We'll be using the package ggplot2. And first of all, we'll make a very, very simple plot, and we will increase complexity as we go. And hopefully that will give you an inspiration to play with your own data later. So, of course, for playing around with data, one needs some data to play around with. And I'll be using some data from my PhD. It's been published in Royal Society B. Feel free to read about it a bit more. And actually, you can also just download it in the Dryad repository, so feel free. But to give a very, very short, quick, and dirty introduction, basically, some time ago, I had the chance to participate in a study where I infected 108 fish with 3 parasites each on day 0. And then I inspected parasite load every 3 days for 15 days. And basically, this data contains records of parasite load over time. All right, so basically, as all the data, this data also ended up in Excel. So now we have an Excel. So what now? So I import my Excel to Databricks, and then I want to lead you how I start looking at my data. All right, now we are in Databricks. So I have already defined an R data frame called parasite, and we are in the new cell already. And here we want to define what we want the cell to run R. So we will run a magic command called R, and the package ggplot is already installed in Databricks. So therefore, I will just call the library ggplot, and hereby we will construct our first ggplot of the day. So first of all, we want to define our data source, and our data source is going to be this R data frame called parasite. And then we will define the aesthetics. So hereby my predictor variable is measure, which is the days where I measure the parasites. And my response variable is total amount of parasites observed. And I'm creating a scatter plot, therefore I call it geometric point. And let's run the cell and see what happens. All right, so let's see what actually happens. So here is our first very simple plot. So as you can see, yeah, it shows that the amount of parasites seems to be increasing in the days we measured, right? So yeah, so immediately as I look to the plot, I'm like, not very happy how my y-axis looks like. So maybe that's something we can start on. So I want my y-axis to show me more labels, not enough labels, right? So I can define it with a function called scale y continuous, and I have already done it before, so I'm just copy pasting it. But basically, I define what labels I want on my y-axis, and then we can run the cell and see what happens. And we can see that, yeah, I defined my y-axis labels. Happy with my labels, but if I look at this plot, it's kind of, it looks like it's only one type of treatment in my fish, right? But actually, I studied 3 types of size selective treatments, so I would like it to be visible when we look at the plot. So actually, for that, I could define it in my aesthetics section. I can just add a very simple thing called color equals treatment, and let's run it. And we can see that actually that made treatments by color, and it automatically added the legend even for my different treatments. But if I think about like looking from the color perspective, Uh, Having two different circles, one red and one green, is not the most inclusive. The one thing which I want to include is actually that the treatments are in different shapes, because then more people are going to be able to read the plot. And for that, I can just define in our aesthetics that I want my shapes to be different by treatment. And I run the cell. Yeah, and we can see that we so simply have changed the shapes of our plot. And another thing, if like I look at this plot, is actually I don't like this measure part, because actually I measure through the days, and I think if I define my x-axis differently, then more people are going to be able to read the plot as they look at it, so they can see that it's total amount of parasite load in the days measured. Let's change that. And actually, that's pretty easy to do. So we can do that with defining our x-axis like we defined with y-axis just before. So I will add a function called scale x continuous. And I want to define which days I measured the fish, right? So it's from 0 to 15. And I want to define that my x lab is called days. Let's see how it ended up. Yeah, I'm actually very happy how it looks like. So basically, now when we look at the plot, we can see that in the days, the total amount is like that. That makes me quite happy. But then one thing I'm always like curious about when I'm exploring data as I am today is a little bit about the stats. So how does the treatments actually differ from each other? So let's try that. So we suffered through the most difficult part is to get to something meaningful, right? But the one thing is actually, I think, would really help to get it even more meaningful is we can see that these plots kind of overlap, and I would quite like that uh, it differs by treatment. So actually, I will use a function called facet trap by treatment. I have two pluses that I don't need. And here I will just, yeah, it separated my plot by different treatments. So I actually already like this plot. It's quite obvious and it tells the differences, and I think there's no point of overdoing. I don't quite like this background. My favorite background is team black and white, that we can do really simply. All right, so here we are. So basically, we have already made a plot, but I just wanted to show you how much you can actually customize. I actually have three treatments within my treatment, which is called population, and I actually would want different shapes for populations, and also I would like different colors for my treatment. And I have already looked into some colors, and I can define all of them manually by what I like, and I can define my shapes as well manually. And yeah, so basically, if you want, you can actually create this really colorful plots, which of course I would recommend to use more contrast shapes, but for this I just had so much fun to play with colors. So happy plotting, now you know everything. I really hope that you got some inspiration to draw some amazing plots. And thank you so much for bearing with me in this video. I feel so honored to be featured in Data Popcorn this year. And feel free to connect with me on LinkedIn and send me your plots. I would be very happy to discuss it with you.